Hello and welcome, this is Alex and we are in lesson 3, our scene system or controller, call it whatever. The idea is to have scenes on top of the Unity scene, but not necessarily on top of Unity scenes, because this is something that works standalone. I mean, we have our own scene, which can contain data. For example, let's imagine that we want to track player statistics or I don't know, whatever other thing. We will have our gameplay scene and we can have this information within that gameplay scene in order to avoid having that in the gameplay controller or some other class located somewhere we have no idea where. So well, the scene itself is pretty simple. You enter in a scene and you exit from a scene. Because you have an on enter and on exit. Then we load the scene, which is using an async operation, which calls the scene manager to load the scene async, if it's additive or if it's just normal, and then we will wait until that scene loads. We are using our timer system in order to call this function recursively. So instead of using a coroutine, we are avoiding that thing so that way this code can be ported to any other engine, like Godot, for example. Obviously, Godot doesn't use scenes, but you get the idea. Well, anyways, the point is that we load the scene. When the scene is loaded, we send that callback, and we call the onScene loaded in order to do things in our inherited scene. Like, I don't know, for example, I use the onScene loaded to call the bootstrap, so that way I can launch all the tasks that I have for such bootstrap. The scene contains the scene data, which is the data that we will find within the JSON file, which will contain the scene name, our class, the Unity scene, if any, which will be the next flow within the state machine, and the bootstrap area, if any. So we pass those things, we store those things in there, and then we can call them within our scene in order to load that scene nonetheless. So let's, for example, take a look at this. I have created this menu scene, which inherits from the scene. I'm storing the things that I need to load that. I'm overriding the configure in order to get what the scene I need to load and what will be my bootstrap area to load. I call on enter, I load the Unity scene that I have attached because I have that name. I have this callback in order to update any kind of progress bar or whatever thing. And when the scene has been loaded, I set this enter completed, and now I can do things because my menu scene has been loaded, that Unity scene. So now that the Unity scene has been loaded, I can, for example, open the UI or call my bootstrap area, for example, and do things. So it's up to you. From this point, you kind of regain control of your flow in order to do anything that you want. As an example, I have here this kind of menu, so presumably I will have some sort of menu screen, so I will get that menu screen through our core, and then I open that menu screen, and let's say my game will start. You don't necessarily need to do that. And on exit, for example, in this case, I'm not doing anything. I will clean up whatever kind of thing I had in here. Let's say clean up. And now the important system, our scene changer system, which will have the reference to the current scene that we are loading. What's our current scene? Our temp in order to load and do those kind of things. I have my scene stack in order to store how many scenes I want to load. The scenes will be loaded one by one, and one scene overrides the other one, so watch out with this. I mean, the system only allows to have one scene active at a time. If I load 3 scenes, it's because I want to load, let's say, scene 1, because a scene 1 is some sort of bootstrap area and I want to load things, then scene 2 for whatever other reason, and let's say finally scene number 3, which will be the game itself. So this stack will be loading those scenes one after the other and overwriting this current scene with which whatever the scene has been actually loaded. So watch out with this. We have the load new scene. Someone will be passing our loading a scene. We copy our callback, blah, blah, blah. We call the change to scene. We check the stack. We add the scene to the stack. Then we set our pointer to the new scene, we call on enter, and then we wait for the new scene to be completed using our timers one more time nonetheless. So this is pretty much the scene thing, and let's take a look at the testing itself. So somewhere I will call this menu scene, I will create the object, and then I will call the core to say, okay, load this scene, the object that I have passed, and I will have this callback in order to do whatever thing I want to do with this scene loaded. Right now, this system doesn't serve any purpose as it is. I mean, you can use it, of course, but this will be later on integrated within the state machine. I mean, the state machine will call the scenes and will call the instruction controller that we will see in the next lesson, and any other system that might be affected by that kind of flow or loading flow things. So right now, like I said, these scenes are kind of like, well, you can use it, why not? But they don't serve any real purpose or real advantage to whatever thing you have. But like I said, later down the road in this course, we will see the use of this kind of neat system. So well, until then, I will see you in the next lesson. See ya!